This video is a review of polynomials and exponents, so it's going to move pretty quickly. I'm going to sort of give a little introduction to each of the different topics here, but if there's more that you need, look back through the textbook of these individual sections because this material is not really considered new material for this course. It's considered a review, but I do think I want to go through and at least give you some of the highlights of polynomials and exponents since this is going to be important as we move through the next couple of sections. All right, so if a lot of this seems like you've seen it before, it's probably because you've seen it before. So the first important thing is the idea of an exponent. If you have some base to a power, that doesn't mean you're multiplying by that power. That means you're multiplying the base by itself that many times. So my example here was 2 to the 5th. So if I write 2 to the 5th, that is not 2 times 5. 2 to the 5th is 2 times 2 times 2 times 2 times 2. So 2 multiplied by itself 5 times. So 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. Notice the one down here with the negatives. Negative 4 to the 3rd with the negative sign on the inside. 3 on the outside means negative 4 times negative 4 times negative 4. That actually gives you a negative number, right? Negative 4 times negative 4 is positive 16. Multiply that by negative 4, and you get negative 64. All right, so it says write in simplest exponent form. Look at this first one. 3 times 3 times 3 is 3 to the 3rd. X times x is x squared. For the second one, you've got a negative 4, but no other negative 4, so that just sits by itself. You got 1, 2, 3 m's. You've got 2 n's. All right, so suppose you want to multiply two powers with the same base. All right, if I have 2 to the 3rd times 2 to the 5th, what does that mean? 2 to the 3rd means 2 times 2 times 2. And then 2 to the 5th means 2 times 2 times 2 times 2 times 2. So how many 2's do I have? Too many. No. 1, 2, 3, 4, 5, 6, 7, 8. I have 2 to the 8th. So you realize I could have gotten that at the beginning by saying, look, 2 is the same base here and here. Just take those exponents and add them together. Because what did I do when I wrote it out? I took 3 of them plus 5 more of them. I got 8 of them. Right, so that is what we call the product rule. Look at these x's. I get x to the 2nd times x to the 7th. Add the powers, you get 9. So the rule is same base, add exponents. That's how I think of it. This only works, obviously, if it's the same base. If I were doing something like 3 to the 4th times 2 to the 5th, that doesn't work because I've got different bases. I've got 3's and I've got 2's. This only works if the bases are the same. So if the bases are the same and you're multiplying the two numbers together, then just add the exponents and you're done. So suppose I gave you powers like this. Right? The first one's easy. 4 squared times 4 to the 3rd, same base, add exponents, 4 to the 5th. For the second one, I've got 6 of them. I've got 8 of them. 8 plus 6 is 14. Ones down the bottom are a little more complicated, so let's take a look at those. I've got a 2 and I've got a 6. 2 times 6 is 12. There's nothing else I can do with that. Now look at the p's. I got 4 of them here. I've got 5 of them there. 4 plus 5 is 9 of them. All right, look at the next one. Look at my coefficients. Coefficients are the numbers before the variable. Negative 3 times 5 is negative 15. Times 2 is negative 30. Now look at my y's. I got 3 of them plus 7 of them. That's 10. But really, that thing there is a y to the first, so don't lose that one. 3 plus 7 plus 1 is 11. All right, number 5 has a constant and 2 variables. All right, let's just make sure we keep them together. 7 times 3 is 21. How about my x's? I got 4 of them here, but don't forget I got another one here, right? That's really an x to the first. So 4 plus 1 is 5, so that's 5 x's. Now let's look at the y's. I've got 3 of them here and 6 of them there. If I'm multiplying, that's 9 of them. All right, for number 6, I'm going to take my coefficients and multiply them. 2/3 times negative 3/4. Oh, look, the 3's cancel top and bottom. And actually, there's a 2 that cancels top and bottom here. 4 divided by 2 is 2. So it gives me a negative 1 on the top, a 2 on the bottom. Look at the m's. I've got 4 of them here, and don't forget another 1 there. So 4 plus 1 is 5. Look at the n's. I've got an n to the 0 times n to the 6. So there's two ways I can look at that. One is simply add 0 plus 6, and I get 6. The other way to look at this is anything except 0 to the 0 power is just 1. So I'm saying 1 times n to the 6th, which again is n to the 6th. So for those 0 powers, you can treat them as 1, or just use that same rule, add the exponents together. All right, power to a power multiply. Why does this work? Take a look at my 3 squared to the 4th power over here. 3 squared to the 4th power means 3 squared times 3 squared times 3 squared times 3 squared. So there's 2 3's, then there's 2 more, then there's 2 more, then there's 2 more. 2, 4, 6, 8. There's 8 of them. Which is the same thing I would get if I took that 2 times 4 and multiply it. So a power to a power, multiply. If you've got a product raised to a power, so for example, a 4x to the 3rd, something like that, then the 4 gets raised to the 3rd power and the x gets raised to the 3rd power. So 4 to the 3rd is 64, so I can simplify this as 64x cubed. All right, for quotients, the power on the outside goes to everything on the inside. My little hint is simplify the inside first. So for example, if you had something that could be considered a little bit messy, like a 6x squared y over 2x cubed y, and you were going to raise this whole thing to the 3rd power, rather than raising every term on the top and every term on the bottom to the 3rd power and then simplifying, I would simplify the inside first. So when I simplify this inside part first, 6 divided by 2 is 3. I've got one more x on the bottom than I do on the top. And the y's actually cancel out, right? There's a y on the top and a y on the bottom. They cancel. Now do that. 3 to the 3rd is 27. X to the 3rd is just x to the 3rd. Okay, so I can simplify much more easily when I simplify the inside first, if it's possible. If not, then we're just stuck raising everything to those powers. But if we can simplify the inside first, it makes it easier. All right, look at number 2. A to the 0 b cubed to the 4th power. Now again, we can treat a to the 0 as 1, or we can actually raise a to the 0 to the 4th power, and we'll still get a to the 0, right? 0 times 4 is 0. A to the 0 is 1. So this becomes 1 times b cubed to the 4th power. Power to a power multiply. I get b to the 12th. All right, look at number 3. I'm going to raise everything to the 5th power. So I'm going to raise 2 to the 5th power, x to the 5th power, y cubed to the 5th power. 3 times 5 is 15. All right, last thing I do, 2 to the 5th is 32, x to the 5th, y to the 15th. On your calculator, by the way, if you're trying to raise 2 to the 5th power, you probably have a little key that looks like that. We call it the caret key. So you'll probably have to type in 2, hit the caret key, and then the number 5. So give it a try. Hit 2 to the 5th, and you should end up with 32. All right, number 5 looks a little bit messy. Let's see what we can do with number 5. So when I simplify this, I get an 8 to the 4th, m to the 12th. On the bottom, I get 8 squared m squared. So rather than get number values for the 8 to the 4th and the 8 to the 2nd, let me leave it like that for just a minute. And think about it this way. I've got 4 8s on the top. I got 2 8s on the bottom. So I got more 8s on the top than on the bottom. How many more? 2 more. All right, look at those m's. I've got more m's on the top than I do on the bottom. How many more? 10 more. And now 8 squared is 64. My problem is done. All right, number 6 looks like it could get a little messy. Let's try to simplify that out first, and then combine like terms. So everything gets raised to the second power. So I get 4 squared, x squared, y to the 6th, times x times y. All right, so 4 to the 2nd is 16. Look at my x's. 2 of them here, 1 of them there. Same base, add my exponents. I've got 3 of them. Look at my y's. I've got 6 from the first part, 1 from the second part. 6 plus 1 is 7. So it looked messy, but look, we got it done in 1 or 2 steps. Number 8 has a little piece of information I want to pass along to you. That negative 3 gets raised to the second power, right? So that negative 3 gets raised to the second power. The a squared gets squared, so I get a to the 4th. I got a b to the 6th. I've got an a and a b cubed. When you square negative 3, you get positive 9, right? A negative times a negative is a positive. But when you enter that on your calculator, suppose you're going to type in negative 3 squared on your calculator, make sure the negative goes inside the parentheses, and then you raise it to the second power. Because negative 3 squared is positive 9, because it means negative 3 times negative 3. By order of operations, this is negative 9, because remember good old PEMDAS? PEMDAS says square the 3 first, then apply the negative sign. And so that's why we get different answers, depending whether it's in the parentheses or not. So if you want to square negative 3, put the square on the outside. I have on my a's, 4 of them plus 1 of them is 5 of them. And for the b's, 6 plus 3 is 9. All right, we'll make this one a short video. We'll come back and do the second part of the review with polynomial operations next.